In today's class, we will solve a few problem sums based on number systems which are of level 3. So let's get started. First question says that x is a series of 40 terms and y is a series of 20 terms. Then what will be the difference of y and x? So let's write those series first. So in the series of x, what we can see is that we have here 40 terms. First term is minus 23, third term is minus 23, and definitely the fifth term and every term at every odd places will be minus 23 only. Similarly, at second position we have 22, at fourth position we have 22, and again in the sixth position we are going to have 22 only. So at every even position we will have 22 only. And this way we have, as we have even number of terms, so minus 23 will repeat 20 times and 22 or plus 22 will repeat 20 times. So we will have this minus 23 as we will have 20 times. So the summation of all those 20 minus 23 will be this. And then again we have this 22. This term will be repeated again 20 times. So the summation of all those 22 will be 22 multiplied by 20. Now if we apply the distributive law of multiplication, then what we can see is 20 is the common factor here. So if we take 20 common, then within bracket we will have minus 23 plus 22. So finally it will be 20, and from here we will have minus 1. That means finally the value of x will be minus 20. Similarly, y. In this series we have 20 terms, and again what we can see, the pattern is same as x. So here 11 we have at first position, again we have at the third position. So at every odd position we will have 11 only, and we have in the second position we have minus 10, again in the fourth position minus 10. So that means at every even position we will have minus 10 only. And this way, since in this series of y we have 20 terms, that means 11 will be repeated 10 times. So we will have 10 11, and this will be the summation of all those 11, and then minus 10 again we will have how many? 10. So the summation will be minus 10 multiplied by 10. Again it will follow the distributive law of multiplication, and 10 is the common factor. So within bracket we will have 11 minus 10. That means finally it will be 10 only. And then if we evaluate y minus x, then y we have obtained 10 and x we have obtained minus 20. It will be finally 30. Next sum says that if x and y are the smallest and the greatest 4-digit numbers formed by using all these 4 digits 9, 3, 5 and 1, then find y minus x. So first we will write all these 4 given digits, so 9, 3, 5 and 1, and then x is the smallest and y is the greatest. So what will be x? X is the smallest and y is the greatest number formed by all these given digits. So now we need to evaluate y minus x. So if we complete this subtraction, then it will be 8172. So this will be our final answer. Now the next one is again a series of numbers from where we need to find the value of x and y. So let's write those series first. Now in the first series what we can see, the first term is minus 1 raised to the power 1. Then second term minus 1, then power is 2. And the last term is minus 1 and the power is 2009. That means from here what we can understand is in this series we have total 2009 terms. And the power of minus 1 increases by 1 as the term increases. So what we can also say is that the power of minus 1 here is equal to the position of that term. We also know that if the power of minus 1 is odd, then final value of that term will be minus 1. And if the power is even and if the base is minus 1, then the final value will be plus 1. Now in this series what we can see is that at every odd position we have the power odd, and at every even position the power of -1 is also even. And since this total number of terms that is odd, so if we divide into two parts, then it will be finally 104 multiplied by 2 and then plus 1. So there will be odd number of terms whose power is odd, and there will be even number of terms whose power will be even. And at the same time we can also say that we will have this 104, this number of terms where the power of -1 will be even, and we will have again 104 number of terms whose power will be odd. And this extra one, what that signifies? This extra one signifies this is the last term, and last term means this, since this number will be finally even 2008, so 2008 plus 1, so that means this term will be in the odd position and the power of that term will be again odd, and that is actually this term. So from all these what we can conclude is this odd power will be for first even number of terms, and that is 100,004. So -1, and since the final value for the odd power will be -1, so it will -1 will be multiplied by 1004, and then even power again will be for 1004 number of terms, and final value for every term will be +1 since the power is even. So here +1 will be multiplied by 1004, and then the last term is this term whose power is odd, so that value will be finally -1. So if we evaluate now this line, then final value will be -1, as this will give us -1004 and this will give us +1004. So they will cancel each other and final value of x will be -1. Now let's evaluate y. Again in this series we have 2009 number of terms. So again there will be 1004 number of odd terms and 1004 number of even terms, and there will be one more, and since 1000 this will count actually 2008 and then +1, so this extra term again will be in the odd position and that power will be again odd, so this term. Now here -1, and for every odd term this value will be -1 only. So how many terms? -1 will be repeated for 1004 times, and then this term -1 and the power is even, so that value will be 1, and again that type of 1 we will have 1004 times, so it will be 1 will be multiplied by 1004 times, and for every that term which we have at the even position and whose power is also even, that term this time itself is negative. So for every term, as we can see that in the second position, in the fourth position, again will be in every even position that value will be negative. So what we can do is we will take -1 or this negative sign common, and then inside the bracket we will do the multiplication. So this for all the odd terms, this for all the even terms, and there will be the last term which will be again in the odd position. So for that we will have one more -1, right? This is the power is odd, so here the final value will be -1004, and from here the final value will be -1004, and from here it will be -1. So finally the value of y will be -2009, and what we need to evaluate is x minus y, so finally it will be 2008. Now the next sum says that what is the least natural number that should be added to the result of 88 multiplied by 89 so that the sum obtained is a perfect square. So this time we need to add some value. Since we are increasing the value, so the factors, the two terms that are given which actually has been multiplied, and that final result has to be a perfect square. So among these two values or terms, we will consider the value which is highest here or has the higher value, because we are going to add some more value, and the final square value will be basically the square of that number which is highest here. So from these two values, we need to now find that how much is the deficiency that we need to add. So 89 can be written as 88 plus 1 and then multiplied by 89. So it can be further written as 88 multiplied by 89 and then 1 multiplied by 89. So this is the value which was given in the question, and with that if we add this 89, then that will be what? That will be basically a square value, square of 89. That means our answer will be 89. So we need to add this value. Now if the question was like, this time we have been added, so if the question was framed like what should be subtracted from the same result 88 multiplied by 89, then how we would have performed? Then again the same result of multiplication 88 multiplied by 89, and this time we want to subtract. Subtract means we are actually decreasing the value. So when we are decreasing the value of this result of multiplication, then we will consider the value among these two values given or two factors, which one is the lowest or which has the lower value. So this time the square value will be basically 88 multiplied by 88, a square of 88. And then this 88 will be written in this term 89 minus 1, which actually 88. So this will be written as 88 multiplied by 89 and then minus 88 multiplied by 1, that means minus 88. So 88 multiplied by 88, this is the value which was given in the question, and from there if we subtract 88, then what value we are going to get? This value 88 multiplied by 88, which is a perfect square, square of 88. So this time from the given value, if we subtract 88, then we will get a perfect square. Now the next sum says that LCM of two numbers is 420, then which of the following cannot be the HCF of the two numbers? So we need to follow this instruction that cannot be the HCF. We know that LCM is always a multiple of HCF. Now LCM value is given as 420. Now if we factorize 420, then it will be, now after representing 420 by its factors, what we can see is that among these options 70, we have 70 as one of the factors, then 60, yes 60 also we have as one of the factors, then 210 also we have. But what about 80? We don't see any 80 in this factorization or in this representation. So our answer will be that if the LCM of two given numbers is 420, then their HCF cannot be, or it can never be 80. Now the next sum says that if the HCF of two numbers is 18, then which of the following cannot be their LCM? So this is same kind of problem where this time HCF value is given, which is 18, and we need to find among from the given options that which cannot be their LCM. And again the same concept that LCM is always a multiple of HCF. So if their HCF value is given, then from the given options we can easily find that which will not be a multiple of 18, and that will be our correct answer. So 3 to 4, if we represent in terms, or if we want to represent in terms of 18, then it is actually square of 18. So 18 multiplied by 18, then 260, what we can say that it can be represent as 14 times 18, and with that multiplication result we need to add 8 to get 260. Then 648, that also is a multiple of 18, and that can be represented as 18 multiplied by 36. And the last option 360, so it will be 18 multiplied by 20. So 18 This is a multiple of 18. This is also a multiple of 18. This is also a multiple of 18. But what about this? This 18 multiplied by 14. Till this much it is a multiple of 18. But if we add with that value 8 more, then we get 260. So 252 can be a multiple of 18. That can be LCM of those two given numbers whose HCF is 18. But if we add with that this 8, then it becomes 260, and 260 cannot be their LCM value. So our correct option will be option B. So this much for today. Stay tuned for new problem sums. Thank you.